good about forgetting to turn on the recording.
Okay, please
So
go.
by all means, you can take the screen over and proceed. Thank you very much for those. Oh, sorry. Let me introduce you. Our special guest speaker tonight is Dr. Abraham Avi or Avi?
Avi. And by the way, I'm not allowed yet to share my screen. You should make me a call.
Oh, isn't it? Okay, should. Let's see, why am I not?
You just need to click next to my image and make me a co-host. Then I'll be able to present.
Okay.
Or you should enable screen sharing at the bottom.
There you go with co-host.
It's still not allowing me. So maybe at the bottom there is share screen and you just need to click on the arrow to the right of that.
Okay.
And make it enable it to multiple panelists.
Yes, it's marked as all panelists.
Yeah, I just did it myself because you allowed me to be co-host. I was able to do it. Okay.
Oh, okay.
Please. So should I start?
Let me give a little bit of background about you.
Okay.
Thank you, Laurie, for contacting Dr. Loeb. Really interested. He is quite an established astrophysicist. He is a Frank B. Baird Jr. Professor of Science at Harvard, if you really want to be insulting, I guess. A best-selling author and quite known internationally. Wall Street Journal in the US, Publishers Weekly, Die Zeit, Der Spiegel, El Express, and any number of other news entities around the world, printed and online and major networks. He has worked on any number of initiatives supported by the Strategic Defense Initiative. He has done quite a variety of things. For as young as he looks, he's been around for quite some time. That's kind of interesting. But we are going to talk with him tonight, or have him explain to us tonight, the variety of topics from the Galileo project and its multiplicity, his book, Extraterrestrials, the search for technology in space. For those of you who are not familiar with him, it's a fascinating, beyond SETI type of looking at the issues that we can't presume to be alone in the universe. And I wholly believe that he mentions that it's rather presumptuous of us to think that we're it. But there are ways that we need to be looking for the signs, and I'm going to let him explain the various projects that he is involved with. It's quite encompassing. So, Dr. Loeb, thank you again. We really appreciate you being our special presenter tonight, and I'll let you take the floor.
Thank you. So as I mentioned, NBC will air in about an hour and a half a segment that I will show you at the beginning. It will save me some time from some of the slides. So let's start with that. And then there would be another short snippet from a conference that took place last week. So let me share my screen. I hope you can see it. Are you able to see my screen?
Yes, we're seeing.
Okay.
Yeah,
that's okay. I know
what you believes alien tech. Yes.
I know what you are seeing. I just wanted to check
the
screen. Okay. So let me show you the NBC segment from tonight. At Harvard University, in the coming months, I'm going to lead an expedition to Papua New Guinea to scoop the ocean floor and search for fragments from the first interstellar meteor.
Although Avi is in search of what he believes may be alien technology, proof of extraterrestrial existence has never been what's driven his life's work, until now.
I'm hopeful we will find something. The question is, What is it? An unusual rock, a natural object, or artificial?
Despite being the longest serving chair of Harvard University's Department of Astronomy, it wasn't until recently that he started to investigate the possibility that there is life beyond our solar system.
I found a catalog that the government compiled of meteors that were detected by government sensors that are missile warning system. I asked my student to check if any of the meteors, the fastest moving meteors, would have arrived to Earth from outside the solar system.
There was one in particular that sparked the interest of Loeb and his student, Amir Siraj.
We decided to write a paper about this meteor, which was discovered on January 8, 2014. Light from the explosion was seen by government sensors.
Despite the government releasing limited data, he had discovered something groundbreaking. His paper laid out what he believed to be true. But 3 years after writing his findings, a major development confirmed what he knew all along.
After a few years, the release of a letter from the US Space Command in the Department of Defense stating explicitly that this meteor at the 99.999% confidence level came from outside the solar system.
Based on the speed of the meteor and how much of the object burned upon entry, Avi determined that it must be made of a material that is tougher than iron.
And so this one was an outlier in terms of its composition. It was also an outlier in terms of its speed outside the solar system. It moved at least twice as fast as stars move relative to the sun in the vicinity of the sun.
Armed with new evidence validating his findings, Avi decided to take action and make moves to recover the object, his next hurdle. Funding through private donations, he has secured a portion of the money to take the trip.
Let's continue to look for objects like it. It was obvious to us that we need to go there and collect the fragments, because to do the same thing for an object in space would cost more than $1 billion. For a cost that is 1,000 times lower, we can go to the ocean floor and collect material from an interstellar object.
Now, Avi has the task of finding an object that most likely fractured on impact, leaving fragments possibly the size of pennies lost at the bottom of the ocean. It's a challenge that might seem insurmountable in the vast existence of the Pacific Ocean. But Avi is confident they will recover what they are in search of.
It's a fishing expedition, literally speaking. And what we can do is basically take the trajectory of this meteor and extrapolate it all the way to the ocean surface. Now, of course, when the explosion took place, there were fragments generated and they were scattered over a region. One imagines that the tiny pellets would be carried farther away from the point of impact, whereas the heavier fragments will sink down closer to the impact. Finding a big chunk can inform us much more about the structure of the original object. We're planning to board a ship and build a sled and a magnet attached to it that will scoop the ocean floor, and we will go back and forth like mowing the lawns across the region 10 kilometers in size, and collect with the magnet all the fragments that are attracted to it, and then brush them off and study their composition in the laboratory. This will be the first time that humans put their hands on the material that makes an object that came from another star.
With more advanced technology in our skies than in any other point in history, new findings are becoming far more frequent and impossible to ignore. Thanks to a government report that was released last year, the possibility of extraterrestrial life and the pursuit of proof of its existence is finally losing its stigma.
The stigma has been reduced.
It would be the most important scientific discovery that humanity ever made, because if you think about it, it will change our perspective about our place in the universe.
With science in his corner, this professor is not intimidated by critics.
It's not a philosophical question whether we live in an environment where objects are floating around that are representing extraterrestrial technologies. We just need to use our telescopes and find out. In fact, we are not even the first to say that. Galileo Galilei said that 4 centuries ago, and he was put in house arrest. today he would have been cancelled on social media. Once I realized that we found an object from a technological origin that was produced elsewhere, I would not seek approval from anyone else. I don't need likes on Twitter. I just want to know what it is. Okay, so that's this segment that will be aired in a couple of hours. You just got a preview of it. And then let me continue with my talk. So I will try to make it brief because this already consumed some time. You can see the cover of my book in the middle. And if I had to summarize it in one sentence, I would say, when you are not ready to discover wonderful things, you will never discover them. And on the right, you see the cover of another book that I wrote last year. It's a textbook on life in the universe. What you see on the left is a picture of a photograph that was hung on the walls of the Berlin-Brandenburg Academy of Science and Humanities. It was taken by the German photographer Herlinde Quilbel, and she came to my office and asked me to write on the palm of my hand the question that I regard as most important in science. And I wrote, "Are we alone?" Now, last week, we had the first conference celebrating the first year of the Galileo project that I lead, and I will describe it in more details in a few minutes. And here is a video that was prepared after this conference. So that's the second segment that I wanted to show you. It's such a great privilege and pleasure to see 70 members of the Galileo project team coming together, celebrating the past year accomplishments of the project. And we are just at the beginning, because in the coming year, we hope to collect data and find out what it shows. We make no assumptions, we are completely agnostic, but it seems like the government is telling us that there are some exciting objects out there that we need to figure out what they are. And that's our hope. For now, we assembled the relevant instruments, we're testing them, and we will soon deploy them and start collecting data, because the sky is not classified, and we very much hope to discover what the nature of objects that the government is talking about and that astronomers are talking about that look like outliers are. Are they technological in origin from another planet, or are they natural phenomena? And the Galileo project aims to find out along 3 tracks. One is looking at unidentified aerospace phenomena in the sky and imaging them in the infrared, optical, radio, and audio bands. The second is rendezvousing with interstellar objects in space and taking a close look at them. It will cost about $1 billion to meet an interstellar object. There is a much cheaper way of doing that, and that is to find an interstellar meteor. We know of one that landed near Papua New Guinea in 2014, and we plan to search for the fragments from this meteor by scooping the ocean floor. And that is the 3rd branch of the Galileo project. So we have very exciting times ahead, and we look forward to what we will find.
So yeah, I'm Ezra. Had a great time on this project so far. It's been great working with the team that we've had. You know, come to the rooftop, hitting your thumb with a hammer, sweating all day, lifting heavy objects, and just, you know, working with several of the teammates that have been here for, you know, up on the rooftop with me for a few weeks or, you know, a couple months now. It's been an honor to work with them and meet these people. Excited for what the future holds. This is just, a preview of what's to come. Getting a first look at our instrumentation, getting our hands on it, it's working and we're getting data. And now is, what I consider really the start of things, where we get to put in some really nice sensors and expand our reach and set up at different locations. And that's where the real exciting parts, come together, and really looking forward to this next year.
Okay, so now let's get quickly through the rest of the talk, and I will be glad to answer any questions you have. So first of all, the perspective. What did science teach us? By now, we know that about half of the sun-like stars like the sun, have a planet roughly the size of the Earth, roughly at the same separation. So that means that we are not privileged. And in fact, there are more Earth-like planets in the observable volume of the universe than there are grains of sand on all beaches on Earth. So that teaches us some sense of modesty. And if you look at the kings or emperors that conquered a small piece of land on Earth and were very proud of themselves, that's not very impressive. It's like an ant hugging a single grain of sand on the landscape of a huge beach. But I can understand where it's coming from, because when I watched my daughters when they were young, they thought that they are the smartest in the world because they compare themselves to the family members at home, until we took them to the kindergarten and they met other kids. And so for our civilization to mature, we need to meet others. And my point is that Albert Einstein was not the smartest scientist who ever lived since the Big Bang, because most stars formed billions of years before the sun. So it's very likely there were scientists smarter than Einstein on another planet around another star 1 billion years ago, and they had plenty of time to populate the entire Milky Way galaxy with probes, some of which will be near us in the solar system. And I call these artificial intelligence astronauts, or AI astronauts, because across the galaxy, there is no way that such a probe will wait for guidance from the sender, because it takes tens of thousands of years, even for light, to traverse the Milky Way galaxy. So any system that goes great distances has to be autonomous to operate on its own. And for that, artificial intelligence is very helpful. Now, if we try to examine what is around us, of course, that's the correct approach. Looking through our telescopes, what do we find? Well, over the past 5 years, the first objects from outside the solar system were reported. The first report came about an object called Oumuamua, which means a scout in the Hawaiian language. That's the subject of my book, Extraterrestrial. If you want to learn more about it, check out my book. And it was discovered by a telescope in Hawaii as the first interstellar object that came from outside the solar system. But then it didn't look like any of the objects we've seen before in the solar system. And then you already heard about another one, and the other interstellar object that the Earth collided with. It was a meteor that exploded in the atmosphere as a result of the friction with air. And then the government confirmed the fact that it came from outside the solar system. This one was discovered in 2014, about 4 years before Oumuamua was discovered. And the government also released the light that was emitted from the explosion of this meteor. And from that, we infer that it's tougher than iron. In fact, it's tougher than 273 objects in the same catalog that the government compiled. So we are planning an expedition to Papua New Guinea, where the meteor landed. And we know the area, and we have an expedition team that includes people who have a lot of experience in such missions. And what you heard is actually the seismometer signal that was recorded on Manus Island near Papua New Guinea when the first interstellar meteor exploded. So that's sort of like the sound of the universe knocking on our door. And we will go there and scoop the ocean floor. It's about a mile deep. And we will use a sled and a magnet to collect the fragments. We're currently raising the necessary funds. I received a donation for $500,000. We still need another $1 million or so in order to make it happen. And as it turns out, I just received an email from someone that might be interested in providing those funds just half an hour ago. So Oumuamua was much bigger than this meteor. It was roughly the size of a football field, whereas the meteor was the size of a watermelon. But we could see the meteor simply because it exploded. It generated its own light. Oumuamua did not collide with Earth. It just reflected sunlight. So in order for us to see it, it had to be much bigger. And it came from a very special frame of reference, the so-called local standard of rest, which is the frame that you get to when you average the motions of all the stars near the sun. And only 1 in 500 stars is so much at rest in that frame as this object was. So it couldn't have come from any of the nearby stars. And then when it came close to the sun, it was tumbling every 8 hours. And the amount of sunlight that was reflected from it changed by a factor of 10. And that meant that it has a, excuse me, someone is not muted. And that meant that it had a very extreme shape. Just imagine a piece of paper tumbling in the wind. It's razor thin, but the area that you see, if it changes by a factor of 10, it means the object is really thin. Because it doesn't always line up edge on with your field of view. And actually the modeling of the reflection of sunlight from this object implied that it's most likely flat. At the 90% confidence, it's disc shape. And that doesn't look like the typical rocks that we see in the solar system. But the most peculiar fact about it is it exhibited a push away from the sun by some mysterious force. And there was no cometary tail at all. There was no rocket effect to push it. The Spitzer Space Telescope looked very carefully around it and didn't detect any trace of carbon-based molecules, usually characterizing cometary tails. So the only explanation that I could come up with for the push that this object had away from the sun was to say that the reflection of sunlight is pushing it. But for that to be effective, the object had to be very thin. And nature doesn't make thin objects that are flat. So I suggested in a scientific paper that maybe it's artificial in origin. And there were some other anomalies of Oumuamua. But let me just say that the only proposals that came from the mainstream of astronomers that said it must be natural, they all said it must be natural, but it's a rock of a type that we've never seen before, or an object of a type that we've never seen before. For example, one explanation was maybe it's a dust bunny, a cloud of dust particles that is 100 times less dense than air. And by reflecting sunlight, it gets pushed away. The problem is that such a cloud, 100 times less dense than air, would get heated by hundreds of degrees when it comes close to the sun and will disintegrate, doesn't have the material strength to survive. Then there was a suggestion maybe it's a hydrogen iceberg, a chunk of frozen hydrogen. And here again, such an object would not survive the journey in interstellar space because hydrogen evaporates very quickly. So the idea behind suggesting that it's a hydrogen iceberg was that we can't see the hydrogen, it's transparent. So it could be a comet made of pure hydrogen. We've never seen anything like it. We don't know if nature makes such things, but that was a suggestion by astronomers that wanted it to be natural. And then, given the problem with the hydrogen evaporating too quickly, there was another suggestion that maybe it's a nitrogen iceberg, a chunk of frozen nitrogen chipped off the surface of a planet like Pluto. But the problem there is the mass budget. If you take all the solid nitrogen in Plutos around other stars in the Milky Way galaxy, there is just not enough material to make a large enough population of chips such that we would see one of them as Oumuamua. So there are challenges to all of these possible explanations. And the fundamental question is whether Oumuamua was natural or artificial in origin. And the way I think of this is if you walk on the beach, most of the time you see rocks or seashells that were naturally produced. But every now and then you see a plastic bottle. And that indicates that there is a civilization nearby. So perhaps Oumuamua was a plastic bottle. There was another object discovered in September 2020. It was given the name 2020 SO, and it was pushed away from the sun by reflecting sunlight. There was no cometary tail. But a few weeks after the discovery, with the same telescope that discovered Oumuamua, the astronomers realized that it's actually, if you trace the trajectory back in time, this object was a rocket booster that was launched in 1966 by NASA to the moon. And it had very thin walls, and that's why it was pushed by reflecting sunlight. So we know that it was artificial in origin because we produced it. The question is, who produced Oumuamua? And the typical response of those that argue that it's a rock of a type that we've never seen before is just like a cave dweller that is used to playing with rocks all of his life. So if imagine the cave dweller finding a cell phone, the immediate response would be, it's a rock of a type that I've never seen before. But if the cave dweller would press a button, then he would realize that this object records his voice, another button records his image. So clearly it's not a rock. And so in order for us to find out that Oumuamua was not a rock, we need more data. And I would love to press some buttons on unusual rocks of this type. I should say there was a wine that was produced by a vineyard in Santa Cruz that was inspired by the story of Oumuamua, by my work on the subject. And in fact, they shipped bottles of this wine to the conference last week. We drank it at the banquet. Here's another thing that was inspired by the book. Let me play it.
Daily double. You are well in the lead at 4,400. How much would you like to wager?
Let's do 2,000, please.
Here's your clue. I look at the world and I notice it's turning, thanks to this man who studied at the University of Krakow in the 1490s.
Who is Brahe?
No, correct response. Who is Nicholas Copernicus? You lose a little bit. Pick again, Robin.
Scientist for 600.
We think of this Russian who became a professor of general chemistry in 1867 periodically. Robin.
Who is Mendeleev?
Yes.
Scientist for 800.
Avi Loeb thinks a space object seen in 2017 and artistically depicted here comes from this 16-letter type of being, the title of his book. Kevin.
What is extraterrestrial?
Correct.
Scientist.
Daily.
Okay, and there was also, I should say, a year ago, there was a sermon delivered about the book by a rabbi in Ann Arbor. And I found that interesting that, in fact, the content of the search for extraterrestrial intelligence touches religious people as well. So the past few years were quite unusual in the sense that there is now a new frontier in astronomy, which is the study of interstellar objects. There are actually 3 of them, the 2 that I mentioned, plus also one that looks just like a comet. That was the third one, called Borisov. So out of the 3 that came into the solar system, 2 are very unusual. There are outliers, the meteor and Oumuamua. And Enrico Fermi asked the famous question, where is everybody? He asked it 70 years ago. And of course, to find our neighbors, we need to look through the windows. We can't just ask this question, and we better use telescopes. And this is the reasoning for the Galileo project. There is also a new era in government, in the sense that the Director of National Intelligence delivered a report to Congress a year ago. There were a number of congressional hearings related to it. A new office was established in government to look at unidentified aerospace phenomena, objects that the government is unable to identify. And NASA last month established a new committee that will study those unidentified objects, the data, the unclassified data on them, and will recommend future funding for research on this subject. There is also a new legislation right now to guarantee job security to those who report about such objects. So I should say that astronomers look at the sky, but first of all, they don't look at objects that are very close, like in the Earth atmosphere. They simply ignore anything in the Earth atmosphere. And moreover, objects that are small or move very fast were ignored in previous surveys. So the coming years will be very exciting as we get more data. And the Galileo project is a key for that. And you might be familiar from SETI, you might be familiar with the Drake equation that quantifies the likelihood of getting a radio signal from another civilization. But that's just like trying to have a phone conversation. You need the counterpart to be active. If you wanted to have a phone conversation with Wolfgang Amadeus Mozart, you would never be successful. You would wait online and nobody would answer. And the point is that most civilizations that existed may have died by now because they existed billions of years ago. So trying to listen to the radio signals doesn't make much sense. But if they sent spacecraft or probes to space, we could still find them. And the equation that gives us the likelihood of finding objects from another civilization is simply related to the volume of the survey times the number of objects per unit volume. They keep accumulating over time. So it's very different from the Drake equation. Also, if you use the Earth as a fishing net to collect interstellar meteors, then the speed of those meteors relative to the Earth matters as well, because that fixes the flux of such objects that collide with the Earth. And of course, the number of objects and their speed will probably depend on their size, because NASA sent many more small objects than big objects. In fact, NASA never sent an object as big as a football field, the size of Oumuamua. And finally, there should be a factor that I call the ostrich factor, which is the likelihood that we would behave like ostriches and not check at all, which was the practice until recently. Because the likelihood of discovery in this case depends also on us, not just on them. If we avoid the search and argue that everything we see in the sky must be natural, it's always a rock, even if it's a rock of a type that we've never seen before, it must be a rock. Let's stop the discussion about it. It's a nitrogen iceberg and forget about it. It's not exciting. Then we will never find anything technological in space. Right now on Mars, there is a rover. It's actually a robot called Perseverance, and it's operated from Pasadena. And of course, if we find microbes on Mars, we would not feel threatened because human intelligence is superior to whatever the microbes possess. So everyone is happy talking about finding microbes. But just imagine that the same rover would bump against the wreckage of a spaceship that represents technologies that we don't possess. That would be a blow to our ego. It would mean that there is a smarter kid on the block. And that would bother a lot of people. They don't want to hear about that. But it is often said that a picture is worth 1,000 words. Irrespective of what people want to hear about, a picture will reveal the truth. In my case, a picture is worth 66,000 words, the number of words in my book, Extraterrestrial. I wouldn't write the book if we had a picture that shows that Oumuamua is a rock. Why would I write a book if we had clear data about it? And you can see an image like that on the right-hand side here of a rock. This picture was taken by the OSIRIS-REx mission to the asteroid Bennu. And when it landed on it, you can easily see that it's a rock. There is no argument. And this mission will bring a sample of this rock back to Earth next year. So part of the Galileo project is to design a space mission that will rendezvous with the next Oumuamua, sort of like dating the next Oumuamua. And there is a dating app called the Vera Rubin Observatory in Chile that could identify many more interstellar objects like Oumuamua, because it will survey the sky starting next year with a camera that has 3.2 billion pixels. And it will scan the southern sky every 4 days. Just imagine, this is the biggest video ever taken of the sky with 3.2 billion pixels. Just remember that any cell phone camera you often use is millions of pixels, a factor of 1,000 less pixels. So this camera is 1,000 times better resolution of the sky. And that would be a dating app that we can use to find those interstellar objects. Most of the time we will swipe to the left, but we might select an object that we want to rendezvous with. And we have to be selective because such a mission will cost $1 billion. So it's a very expensive date. You don't want to date a piece of rock for $1 billion. Or you might, but it wouldn't be as exciting as coming close to something like Oumuamua. And the other thing that we have now is the Webb telescope, which is about 1 million miles away from Earth. So if an object comes along, it would look at it from a different direction than the telescopes on Earth. And so if we have two telescopes, just like having two eyes looking at an object, we can pin down the motion of the object in 3 dimensions. That's why humans have 2 eyes, so that we can figure out the distance of a threat coming towards us. And perhaps Oumuamua was thin because it was carrying a message. It was just like a leaflet. Now, one thing to keep in mind is we sent out spacecraft that will exit the solar system, and one of them was New Horizons that went to study Pluto, but now it's making its way out of the solar system. And imagine that New Horizons spacecraft colliding with another planet far away within 1 billion years and landing with fragments landing on the ocean floor on that planet far away. That would be quite embarrassing, because if there are any astronomers on that planet, they might find this box that was attached to New Horizons that carried 30 grams of the ashes of Clyde Tombaugh, the scientist who discovered Pluto. And these ashes are no different than the ashes of a cigarette. They carry no information about the DNA of Clyde Tombaugh. So if the astronomers find it over there, they would say, This makes no sense. This scientific organization called NASA tried to commemorate a scientist by destroying, burning up all the genetic information about this scientist. That makes no sense. We don't want anything to do with these humans. They appear to be quite aggressive and irrational. They have these rituals, primitive rituals of burning the information about the person they want to commemorate. So that's not a very good thing to send to space. But unfortunately, it's already far out there. And I already mentioned briefly the unidentified objects that the Congress discussed and that the Galileo project aims to image. And we have basically an infrared, a visible light, audio system, a radar system, and we will try to take a continuous video of the sky and get high-resolution images of any object in the sky so that we can tell whether it's a bird, a drone, an airplane, or something else. So the Galileo project altogether has this component that will try to identify unidentified UAP, and there is also the plan to have a space mission that will rendezvous with Oumuamua, and finally the expedition to retrieve the fragments of the interstellar meteor. And the project is funded at a few $1 million by people who came to the porch of my home a year ago and were inspired by the vision of my book and decided to donate funds. And I was able to establish this project. And this is the suite of instruments that are on the roof of the Harvard College Observatory right now that we put together over the past year. It includes an infrared camera that you see like a dome, shaped like a dome. It basically has 8 cameras covering the entire sky. And then also a fisheye camera that looks the entire sky in the visible light. I'll skip this, let me skip this subject. And I would just say that people often quote Carl Sagan as arguing that extraordinary claims require extraordinary evidence. Well, my point is that extraordinary evidence requires extraordinary funding. For example, we don't know what most of the matter in the universe is, and we invested $10 billion in the Large Hadron Collider to look for one type of particle that could make the dark matter. We didn't find it, but there were $10 billion invested. And so when we say, where is everybody? First, we need to invest $10 billion. And then ask, you know, we say we didn't find anything. If we invest $10 billion over a period of several decades and not find anything, then we would be at exactly the same point as the search for dark matter is right now. But at the moment, there is no funding for these kinds of studies except through the Galileo project. And of course, we can find evidence for other civilizations by looking for industrial pollution in the atmospheres of other planets or for city lights on the night side of other planets. And there is always a tension between the ability of a civilization to send equipment to space and its ability to destroy itself. So one possible answer to Fermi's question is that most civilizations are dead by now. They lived for a finite time and then they're not around. So we will not find radio signals or laser signals, but we could find equipment that they send to space. It could be in the form of space trash, that equipment that is not functional anymore, just like New Horizons will be in 1 billion years. Or it could be AI astronauts that are functional, like the UAP that the government is talking about. And we don't have a protocol for how to engage with functional equipment. For example, who represents humanity? And if the technology is far more advanced than we possess, we don't know how to deal with it. But my hope is that by finding relics of more intelligent civilizations, we would get inspired, because if you look at human history, it's most of the time shaped by a group of people trying to feel superior relative to other people. The best example is the Second World War, where the Nazi regime triggered the death of 75 million people. That was a factor of 5 more people that died than the number of deaths triggered by COVID-19, for example, just because a group of people decided to feel superior. So my hope is that if we find a more intelligent kid on our cosmic block, that would inspire us to treat each other as equal members of the human species. And we should always keep in mind that the cosmic play has been going on for a while. The universe existed for 13.8 billion years, and we just came at the end. We are not at the center of the stage. So just imagine going on a stage, you're not at the center of it, you just arrive at the end of the play. Obviously, the play is not about you. And that's the message the universe is sending us. And the best way to figure out what's going on in this play is to find other actors. Thank you. I'll be glad to answer any questions.
Thank you, Doctor. That's fascinating. And one comment I had was that even if Oumuamua is a rock, and my background is geology, it could be a rock. But even though we can get to it and sample it and see it is a rock, we know that there are spacecraft out there because we've put them out there. And going on the premise that we are not alone. Like you say up front, it is very presumptuous of us to think that we are it. And granted, we are only one small entity within the universe. All of the other entities that may have come and gone, if they got to the technological point where they could send off vehicles, some of them may be coming within our area. And I agree with you. We need to have more sensitive, deeper space like the James Webb, but for detecting deep space objects from the interstellar medium. So yeah, I just think that you're on the definite right path when you're talking about needing to have better ways of tracking the interstellar possibilities, rather than just waiting for somebody to land on our planet, which may have already occurred or may never occur, but just give us a better chance of finding something out there. And your other aspect of looking for the localized, what is the term again? The unidentified aerial, I forget what the phenomenon. Yes. Okay. Thank you. I'm just hating to use the word UFOs because it's too much of a trigger. So anyway, let me look down in our Q&A area, and for the listeners out there, if you have questions for Dr. Loeb, please, by all means, and for Lori or David or Rick, come online. Oh, what do we have?
Dr. Loeb, you have mentioned on several occasions that one way for looking for these extraterrestrials would be looking for their pollution on and around their planets. Can you give me some probability that their pollution would be something we would recognize?
So you're talking about the slide where I showed that there are other ways of looking for technological signatures. Is that what you're talking about?
Yes.
It may be. I missed that slide as I was checking something else, but
Okay,
specifically.
that was just a side, I just made a side remark that there are other ways to look. Most of my talk was just about objects, but I wrote a scientific paper talking about industrial pollution in the atmospheres of other planets. So just like we look for oxygen or methane or other gases in the atmospheres of planets that are passing in front of their stars. So a fraction of the starlight is passing through the atmosphere of the planet, and then we can look for the fingerprints of various molecules in it. So just in the same way, you can look also for the fingerprints of pollutants that are produced, for example, CFCs that are produced by refrigerating systems and industrial pollution on Earth. So you can look for that also on other planets. And this is a way of finding technological civilization. So that's one thing. And I mentioned also looking for city lights on the night side of a planet. All of this was just a side remark, a footnote in my talk. 99.5% of my talk was about looking for objects.
Thank you.
Thank you. And we have an online question. Is it the case that we have not been contacted simply because nothing travels faster than light? And even if there are other civilizations out there still in existence, how would they contact us?
No, as I explained, you can traverse the entire Milky Way galaxy in hundreds of millions of years. The universe existed for 13.8 billion years. So there was plenty of time, even if you use chemical rockets of the type that we are using, plenty of time to go across the galaxy many times over during the lifetime of the galaxy. So there is no issue with going faster than light. You can go at the speed of a chemical rocket that we are launching, that NASA is launching. It's not even close to the speed of light. It's slower than light by a factor of 10,000. So what I'm saying is if you go as slow as 10,000 times slower than light, you can go through the entire Milky Way galaxy many times over during its lifetime. So you don't need to move faster than light. But you need patience because it takes time to go across hundreds of millions of years. But we had that, I mean, those other civilizations had that time. And so if they existed a billion years before us, by now, the entire Milky Way galaxy might be populated by objects that they sent. You don't need to move faster than light in order to accomplish that.
Thank you. Lori, did you have a question?
Mine's a little bit off the wall. Hello, Dr. Loeb. I'm the one that's been emailing you and bothering you so much. Thank you so much for coming.
My pleasure.
This is a off the wall question because that's my personality, but at the end of my semester that I teach life in the universe, where we're looking for life in the universe, I asked the students, if you were to contact someone from another world and want to tell them about planet Earth and about the beings that live here, what would you say? And they write cute things and sweet things sometimes about wanting to be peaceful and greet them and kind things, but like sending dead ashes into space is kind of futile. What would you want to put on a spacecraft if you were sending a message into space to some civilization we haven't met yet?
Right. So I think there are two possibilities. Either they are much smarter than we are. They have much more advanced technology, given that our technologies improve all the time. So if you imagine us 1,000 years from now, we will have technologies that we cannot even conceive right now. So just imagine someone from a few hundred years ago looking at a cell phone. They would never be able to understand it. And so my point is, we're much more likely to be in a situation like that they are much more advanced than we are, or much more primitive than we are. It's very unlikely that they are exactly at the same phase as we are, because this phase lasted a century, just 100 years out of 4.5 billion years that the Earth existed. So if you find another civilization, it's much more likely to either be more primitive than we are. For example, for 1,000,000 years. We've been in the jungles. We've been very primitive, you know. So it's possible that many of them are primitive, but to find the primitive ones, you have to go to other planets, to go into the jungles and find them there. That's very tedious. That takes a long time to get there, to search. The other possibilities that are much more advanced than we are. And then you don't need to do much because they will come here. Okay, so you just need to look around. And in that case, you know, it doesn't really matter what we write, what we tell them. Just think about ants on the pavement. Okay, so ants can speak among themselves and decide, let's do some hand signals, let's say this, let's say that. But then comes a biker on a bicycle along the same sidewalk, doesn't care less about the ants, doesn't care which crack in the pavement they occupy, whether they are in Russia, in China, in the United States. That's completely irrelevant. It's just like finding a colony of ants on one crack or another. And the ants can talk with each other. What should we do in case a biker comes along? Should we wave our hands? Should we send a signal? Should we show what we accomplished in the past weeks? You know, that's completely irrelevant. The biker doesn't care about it. The biker is far more advanced, looking at his cell phone and so forth. And so my point is, we can contemplate whatever we want. We can sound cute. We can sound sophisticated for ourselves. But they might not care about it because we are very primitive to them. And therefore, I don't think we should put much effort into explaining ourselves. I think what we should try and do is, if there is technology coming in our direction, we should try and figure out what it's capable of doing. Try to understand them rather than the other way around.
Thank you. Yeah, I listened to your Bitcoin conference talk, and the issue about, well, how long do we have when you have some substantially what I call wackadoodle people out there that either want to rule the world like the Nazis, or for some reason just don't get along with people, and they're going to lead us into nuclear conflagration, which may either set us back 2 millennia in development or annihilate the human population so that only the crocodiles, sharks, and cockroaches survive to repopulate and re-evolve into other beings. So what's your, I mean, just kind of like if we're sitting there having a glass of wine or a beer, what's your opinion of the future for us if we can't get our stuff together?
Oh, yeah, so that actually is the subject of my next book, which I'm completing now and will come out exactly a year from now. And I'm talking about the future of humanity. It very much depends on the way, you know, we approach ourselves. And I'm trying to recommend a recipe such that we will survive very long. So I'm not a prophet. I cannot tell you what the future will hold. But in my book, I talk about what we need to do so that we will survive for a long time. And just stay tuned. I'll be glad to speak with the same group a year from now after my book comes out.
Be careful, we'll put you on the list. Do thank you a lot. Okay, yeah, let's see. We have another question, I think, down here. Okay.
It's already an hour, so I have just a few minutes.
Okay, by all means, if you want to look at the questions, can you see the question and answer queue and pick what you want to talk about?
Sorry, you mean in the where are the questions?
Okay, down at the bottom of the top, there should be a Q&A tab.
Okay, I see that.
So if you want to talk about any of those, or
yeah, so the last question is about silicon life, and yeah, I do think that that we should be proud of our technological kids, and we can send them to space. The humans are not equipped to survive in space, so it's very likely that the future of humanity will look very different than what we see right now. And then let's see what other questions we have. Dinosaur planets. How about life? It's not clear to me what the question is, but the point is we might find life as we don't know it on other planets. It may not look anything like life on Earth. So we should be open-minded about that. Yeah, I think, oh, there is a question about the sun, but that doesn't really relate to what I was talking about. The sun is actually positively charged because that's the way it keeps the electrons attached to it. An electron has much less mass than a proton. So while protons are attracted by gravity to the sun, the electrons do not feel as strong of a gravitational force, and they're attracted to the sun because it has a positive charge. So a few electrons left, and the sun is positively charged at 70 coulombs. Anyway, that was actually the subject of the first paper I wrote in astrophysics. So it's interesting this question came up. But I'll be glad to come again in a year after the book comes out. So it was really a great pleasure to converse with you. Thank you for inviting me.
Well, thank you very much. We definitely appreciate you taking the time and tolerating our difference of time zone. And luckily the storm didn't knock the power out and we'd have to delay another year. We apologize for last year's not getting you on board. So we will release you to go about your business. It's probably what, 9:30 there?
Yes.
Or pushing 9:30?
Yeah, exactly.
Okay, well, thank you again, and we'll be in contact next year. Look forward to your book. Thank you very much.
It's a pleasure. Bye-bye.
Bye-bye. Well, that was interesting, controversial, I'm sure, as we've seen online discussions, but it's a topic that's fascinating to me. David Douglas, you want to give us a preview of next month's discussion? I'm holding up the book. It looks backwards if you're looking at it. This is his Discovering Double Stars. I did get the book. As a matter of fact, it did come today. And the nice thing about it, if you haven't seen the online pages for it, it's got Telrad rings to help you locate the little suckers, which is, I mean, being just about 1 degree past a novice amateur astronomer, that's one of the handiest things they ever invented.
So you wanted a quick overview?
Well, if you wanted to say anything about trying to wet the whistle for the audience, get them to come and.
It's gonna be fun.
I am hoping. We're setting the stage. Let's see.
Basically, the concept is in search of double stars, and it's a wonderful thing. We can observe for double stars irregardless of what the weather's doing, unless it's clouds, in which case that pretty well locks us out. We don't care about the moon. It's a concept that can be done visually or with imaging or both, and which I do. And you never run out of targets. There are thousands of them. And there's also lots of ways to research them or simply enjoy them. But one of the biggies is they've got color. Lots and lots of color, as you'll tell by going through your book there, sir. She talks about it.
And if I can get a good enough picture of one with my diffraction grading, I can get a spectrum from it, which is interesting to me.
Yes, you can.
So,
but anyway, I'm putting it all together, and we'll be ready next month, and we'll see if we can put on a good show.
Excellent. And Rick Road Trammell, anything you've got that you want to talk about for the newsletter? You're on mute. You need to unmute. Now try.
Hello.
There you go. Okay, you're on the air.
I hope everybody read it.
At least my part, the president's message, that's the most important.
You do a good job, Rick.
Yes, indeed, I must admit. It's one thing to travel through a bunch of presidents and vice presidents and past presidents, but we like our editor to stay where he's at. It's kind of a prison sentence. Continuity, we appreciate that. Yes. Yeah, question?
Is that Amazon? Or did you order it?
Actually, I ordered it from was it Lily?
Lulu. Lulu.
Lulu.
Oh, okay.
Yeah. And I'm sure next month he'll give you the address or the information for it.
Yep.
So it's a quite an interesting document. And actually you can just print it off yourself because the page, it's free.
Free download.
But you might as well buy it. It's cheaper than a cartridge of ink for your printer. I guarantee that. I think it was 37 after postage. So that's as cheap as a cartridge of ink, which it would definitely eat up. And a ream of paper almost.
Tell you what, have I got a second? Just a second.
Certainly. Go for it.
Going for it. I'm opening up a web page. Hang on here. Astronomy stuff. Okay. If you're familiar with this will just be if you're familiar with it, Cloudy Nights. If you're familiar with that website, down at the bottom of the links, you'll find vendor and group announcements. And once you open up that particular forum, if you do a search on the word double stars or Agnes, A-G-N-E-S, that will take you to a link that has all the ordering information and the pricing. You can get that book in, and it's a good reference to have, but you can get it in 3 different flavors. One's a free download. You can't beat that. You can get it in the spiral bound, which Tom's been showing us here. I've got that, and that's a good recommendation. But you can also get it in hardback. So it's available any one of 3 different ways. She publishes things on print on demand. So no one's holding. Amazon does the hardback. Lulu does the spiral bound. So if you want to get the spiral bound, you got to go through Lulu, but there's a link in that thread, which I gave you. That's on cloudynights.com down at the bottom under vendors. And then you do a search up at the top of the page for double stars or Agnes Clark, and it'll take you right to her thread. There you go.
Just one more thing to do.
There you go.
And we just want some clear skies. Come on, these clouds, this is Arizona, and we shouldn't have clouds all the time, even if it is monsoon season.
One thing we should point out about that particular book, I don't think it says it on the cover, but that covers 300 targets. So if you're looking for something to do, that'll definitely give you something to work on.
Yeah, if you finish your Herschel and the Shapley and the other 30 other odd lists of things to do. But stars are just cool. I won't say easy, but they're fairly easy, and they're a lot of fun, especially when you say you can look at them, especially if you have a good refractor, a triplet that gives you good color, which I don't, which may be the next thing that my stepkids are buying for me with their inheritance.
There you go. There you go.
Well, Jack Jones is not with us this evening. He hasn't passed away or anything. He's just out of state. But he says there's still money in our account, so we're solvent. So speaking of that, we're coming up towards the end of the year. I want all of you to think about ponying up. Right now, we have a board of 2, Jack and me. We need a new vice president. We not need a new one. We need one. We don't even have an old one. And I have finished my 3rd year as president, so I need to be replaced. And I'm sure a lot of you are tired of me messing up on my Zoom meetings.
Oh, no, we're not.
Shut up. Shut up. Yes, he is. He's just saying that to be nice.
I'll second the motion.
Yeah, no, we can't. We're not changing the bylaws or the club. Not happening. Let's see. I can't think of much else. Let me see down the questions what we have here. If anybody, these are all questions from Dr. Loeb's discussion. So anything else that anybody in the Zoom participant group in
How
the
many-
nether world?
How many people did you have in attendance?
We had 21 on Zoom and what, 8 here or 6 here? 2, 4, 6. Yeah, six in attendance.
All right.
So it wasn't bad attendance, especially for a rainy night when I would not be surprised that there are a lot of people who didn't even make it home yet. So with that being said, any other questions? Any weeds, any seeds, any weeds that you don't need? Oh, sorry. I never gavelled us in. Okay, I'm going to gavel us out then. Anything else? We will see you in September. Anybody want to present anything else in September? Please let us know. And anything for the newsletter, let Rick know. We'll talk at you later. Have a good evening. Stay dry.